Okay, welcome to another chapter of Easy Artificial Intelligence R.A.G, Retrieval Augmented Generation. Basically, this is similar to the last chapter. All we're doing here is we're basically feeding in a list of parameters. We have data files input 003, so we have a folder, and the folder is going to contain some text files. Like one is a list of questions, like in the field of artificial intelligence, what does R.A.G stand for? So basically what we want to do is to start with, we want to access a list of URLs, get all the information, parse all the information from the URLs, load all the information into text files on disk, then load those text files from a specified directory, load those into LangChain documents, and then feed those documents into a LangChain chain so that we can ask our questions with it understanding the context. So let's just run through this. You'll see more what I'm talking about. So here we've loaded the parameters, logging. Okay, BeautifulSoup, that's our parsing engine. So we're going to be able to parse a website with BeautifulSoup. Text splitter, we're actually only using recursive character text splitter because this recursive character text splitter pays attention to the chunk size. We've specified in parameters a chunk size, here, chunk size 500, overlap of 50. So it will pay attention to those. Get file contents just pulls when we feed it a file name, this function will return all the lines from that file name as a variable. Clear files, so we'll just clear out the files out of the output directory. Flush file, when we call that, that's the function, flush files. So this function will take base text and a base name and load those text files on disk, create the files on disk. Okay, so here's a function to retrieve the text from the URL. So this function gets an inbound URL. You'll notice here the options is using this Selenium with options, and the argument here is headless equals new. So that's so that it doesn't actually invoke the browser, so you don't see the browser pop up on your system. It basically is running it in the background. Then we're going to parse. So by using Selenium, just to back up a second, we get either the dynamic or static websites. So we'll get all the information. Then we parse all the p tags, and then we'll return each URL as a text variable. So this one we've run. Okay, clear files. So this is going to clear the data files, which we've got this. Well, we're not going to see any in there, but we'll have a underscore 003 in the output. To raise a exception, to check a file, okay, so we're getting the URL list here, list of URLs, and we're getting the query list of query questions. Alternate names for logging the data. Okay, so here's for every line in the URL list, we're going to loop through this, and we're going to use this recursive text splitter to, we're first going to get all the text from the URL and then use a recursive text splitter to split depending on the specified chunk size. Then we'll take the split and flush it. So we flush it to disk. So at the end of this, we can look in that output folder and see the files. It's got a 5-second timeout just so we don't step on ourselves, and I'll pause here for a minute. Okay, so you can see that takes quite a bit of time. It took like 4 minutes to run that section. Here is a list of output files. I've got that short name, and it just it does a splitter and a .txt on it. So if we look at one of these, it's just going to be a chunk as we have specified. So a text chunk, that's what we got, loaded down onto disk. So that's commented out. Here we go. So for each of the question, this is the before. So the before is not R.A.G. So this would be no, Kristen Harla was not accused of climbing over a porter. There are no details, which is accurate if you don't know anything about the event that occurred. So now the next one, we're going to import text loader, and we're going to load in using the text loaders. We're going to create this loaders list, and for all documents, for loader and loaders, we're going to create a list. This took a couple tries to get this right, because if you don't do it in the exact methodology, you end up getting an invalid format when you go to feed it to LangChain. So anyway, this will produce in all documents. Okay, so let's run this, because that was from a previous run. You will get a list here, text objects, loading raw documents. So it could show you each one it's loading, and then at the end, here's the thing I was looking for. So this is the exact format you need to end up with. So you want a list, and you want it to be of type document, and you want a page content and then the metadata with a dictionary. So that is correct. And here's some context here of where some of the specific data is coming from. Here's a little note here. I'm just saying we're not doing any kind of similarity search. So this is brute force. We've got a bunch of documents, and we're going to feed them all in. So this is load QA chain, LLM chain type stuff, and then you can see where we're doing this run, we're loading in that entire documents list. And the question, we're running through the list of questions. So if I do this, this will take just a bit, and you see it starts spitting stuff out. So here's the main thing we're looking for. What does it know about the event? Because this event happened after the LLM was created, after the LLM was loaded. So was Kristen Harla accused of climbing over a porter? What are the details? Yes, Kristen Harla was accused of climbing over a porter. And then it's got the porter's name, who lay dying. Why did the rope fixing team decide it would be safe to split up? So I just pulled some of that from this context here. The rope fixing team decided to split up because they believed Hassan Oh, here we go. Okay, would be getting all the help, and he could, all the help he could. Why did Miss Harla state that it was not possible to help? Miss Harla stated that it was not possible to help because the conditions were too dangerous. Blah, 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 rackety, rackety, rack. So basically what we've done here is we've given the AI a list of websites. We've loaded the context from those websites into text files, flushed them down to disk, and we end up with a whole bunch of text files on this output 003. We end up with a whole list of text files. And then we run the AI LLM with our list of documents that we'd load in from the text files. So that's basically it. Hope you got something out of this. If you want, leave a comment or a subscribe. All right, thanks for watching.